I am Margie Morgan. I'm from Los Angeles. I work at Cedars Sinai Medical Center. And I'm going to talk to you about the Accelerate ARC for positive blood cultures, the new kit and module that they're using for identification of organisms from positive blood cultures. This is where I work. This is Cedars Sinai in Los Angeles. We service about 1,200 in-beds from 2 different hospitals. We are operational 24/7. And the reason I bring this up is, even though all of us do microbiology, we work in very different settings, and not always something that I might just praise and say is the best thing on earth would even work in your institution. So I think it's, of course, important for all of us to take a look at these new methods and see how you could best use it. I'm going to tell you my story of how we're best using the ARC and how it works in my institution, but you might see better or different uses for it depending on what your center is like. We average about 170 blood cultures a day at Cedars, a positivity rate approaching 10%, and we've been lucky that we've been able to keep our contamination rate well below 1%, even during COVID. And I think that's important when you're doing direct methods from blood cultures. We might find it more useful because we tend to have single organisms in blood cultures and not much blood culture contamination. What's our primary services at Cedars? We've always been considered an adult institution. We are getting a new pediatric wing, but we're never going to be a pediatric center. So the methods that I'm looking for are mostly for adults. We have a huge emergency department. We're the primary Trauma 1 center in Los Angeles. A lot of adult medical care, as I said. We're the huge orthopedic center, GI. We're primary cardiac transplant and have more cardiac transplants than anywhere in the United States. A lot of solid organ transplant in a cancer center. So you can see that we might have the opportunity to see some unusual organisms that perhaps are not on usual molecular panels or even identified by the Accelerate Pheno. I think maybe I have a different perspective than perhaps a lot of you. I've been in microbiology for I don't even want to say how many years. But when I started in microbiology, we had really just manual identification methods. And I started with tubes. Can you believe that? You've probably never seen a tube. But we started with tubes in microbiology. And of course, we thought it was when the Vitex showed up with that little plastic card, that was just amazing for us. But of course, times have moved on, and I think that, as you, I would believe as well, MALDI-ToF has truly changed my arena as a microbiologist. And I have been so grateful for the introduction of MALDI-ToF. Of course, when we started off with MALDI-ToF, nearly a decade ago now, we had to grow colonies on agar. It was very fast. It was very accurate for most organisms. The cost savings was really tremendous for us at Cedars. We had so many ancillary biochemical methods that we were using, had to validate, had to QC. We estimate at least we're saving 50% after the initial purchase of the instrument. It gave us the great ability to identify aerobic and anaerobic bacteria, yeast, molds, and mycobacteria. Of course, some of these we did have to do our own verifications and validations, but it really gave us a great ability to identify all organisms. And coming from my ancient history in microbiology, we weren't able to do this historically when I started. We can identify species with similar phenotypic, genotypic, and biochemical properties that was not previously possible. And we recognized organisms that, I have to admit, when I first started microbiology, they were probably diphtheroids and strep species. We didn't really know what some of them were. Now we're able to give them the names with good genus and species delivery. Noteworthy points about MALDI that I have learned over time, and I'm sure you've learned in your own experience, is each commercial platform offers you, I'm sorry, I should advance my slide. Each commercial platform has a unique library of organisms that are identified. And in some cases, perhaps you cannot discriminate between closely related species. But for the most part, I think we rely upon MALDI to provide us very good identification. It also, I find it amazing how timely their library updates are and how they assist with our taxonomy needs. But it identifies rarely recovered organisms. And I don't know how you've all been challenged with this in your own laboratory. And Matt and I was talking earlier, there's actually a talk tomorrow at 8:15 about the taxonomic challenges that we have in the laboratory and introducing these to our physician populations and how we're going to cope with these moving forwards. But it is not uncommon for me to hear from many of the organisms identified from MALDI that I have never heard of this organism. And so that becomes one of my needs as a clinical microbiologist and a director to talk to my clinical physicians about some of these newly identified organisms to make sure they understand what we're reporting from MALDI. It also identifies emerging agents of infection. If we need to identify these correctly, and we probably have not identified them correctly in the past due to archaic methods or their slow growth on agar medias. So we're seeing a lot of new organisms that are very, very important, so-called emerging pathogens. So I have to say that MALDI, for me, in my clinical practice, has revolutionized infectious disease diagnosis and really improved patient care. Also, our antimicrobial stewardship groups are amazed at what we are able to identify and how rapidly we are able to do so. But MALDI is not just content at doing solid agar. We're expanding the use of MALDI-ToF now. There's been identification of organisms directly from positive blood cultures, really since around 2011. There have been numerous publications talking about new methods for laboratory-developed testing for washing, centrifugation, filtration, and extraction steps to purify and concentrate a specimen appropriate for MALDI testing. There was a lot of different techniques. We're not going to go through all of these. I think Matt, following me, will probably discuss some of these as well. But there's numerous techniques in the literature with the same desired outcome. Some type of method to concentrate a positive blood culture to form a concentrated sample for placement on your MALDI target plate. And perhaps some of you tried some of these, or perhaps some of you are even the people that wrote about these techniques. And I applaud you, and I applaud your staff if they were able to accomplish these. We needed assistance. We weren't so good in our staff with the pipetting and filtration and different methods that were necessary. So we were very happy when Sepsityper came out with a kit through Brooker Systems that provided a systematic and kit version for processing and providing a standardized guidance in making a concentrated specimen for us. Of course, the Sepsityper kit, you're probably familiar with it, provides reagents with a stepwise direction to guide you through a multi-step process of washing, centrifugation, drying, and pipetting to prepare an appropriate pellet for testing. Of course, it was a very successful technique, but the estimated time was around 30 minutes for hands-on time in doing this. So what were the pros and cons of doing this type of direct MALDI testing using the Sepsityper kit or some of these that were advertised in the literature? It did provide correct identification of many, if not most organisms, more rapidly certainly than we could with routine methods. Identifications were available within less than or equal to 2 hours after removing your positive blood culture from the automated instruments. It gave you a great potential to decrease time to identification by approximately 18 to 36 hours, compared to routine methods that we had been using in our laboratory. Also, it gave you the unbelievable ability to identify an expansive number of organisms that we weren't able to do in the past from that positive blood culture. It exceeded the organisms on the Accelerate Pheno panel and those that were on molecular blood culture panels. And of course, it was relatively inexpensive compared to some of these methods. But what were the cons of doing manual direct MALDI on positive blood cultures? Well, it's manual after all, isn't it? And it's bordering on tedious. And so when our techs attempted to do this, I don't know if we're all that different. COVID has been hard. We are very, very busy. There has been perhaps limited number of techs at time, but they found that doing things like the sepsittyper was very disruptive to their normal workflow. And they just kind of said, no, thank you. Yes, it works just fine, but no, thank you. I'd rather not do this method. And so, of course, we do have to listen to our techs. It's been a rough time, and we did appreciate the tedious nature of doing the biotyper kit. Also, we looked at when we were performing it, it's most efficient if it's batched. And if you batch it and do it in that way, which would save the tech time at the bench, you increase your turnaround time for results. Publications have varied on how useful the MALDI-ToF is in direct identification from positive blood cultures, but I think most of us would agree it does a very good job in gram-negative rods. It does a pretty good job with gram-positive cocci, usually greater than 80%, but yeast identification still remains problematic when you're testing directly from positive blood cultures. I have to admit we found that a great disappointment. That's one of the things that we were hoping that would be of great use using direct techniques. So how about our attempt at direct MALDI testing on positive blood cultures? Well, we verified and attempted to use a sepsittyper, even though our techs were a little bit against it when we first started. And as we started using it, they became more against using it because it was really disrupting their normal flow on the blood culture bench. But we did find that it did provide rapid and helpful identification. It identified greater or equal to 90% of all of our gram-negative rods. We had about greater than 75% identification of gram-positive cocci, particularly to genus. And once again, it had a low percentage of identification of yeast, which I must say was disappointing. The highest percentage of identification was, of course, using the proper software updates. And I think as we move into doing positive blood culture examination on MALDIs, we're going to find that software is more and more important for the identification of these very early products produced in the positive blood cultures. And updates of software in the future may help us with yeast identification. After doing all of this work, we had to step back and evaluate. And our evaluation showed that I don't think we can move forward with this technique in our laboratory. So why then did we decide to try the ARC? Well, we decided to try it because it had decreased turnaround time, decreased hand-on time in the performance of the test. It only takes about 2 minutes for the text to perform, and it was far less disruptive to their normal workflow than a 30-minute procedure using the sepsittyper. So we had better overall CLS acceptance when we tried this technique. There's individual specimen typing, that can be tested due to the minimal prep time. It doesn't require batching. And we could create workflows, we thought, to use the ARC and MALDI ID to rapidly ID organisms from positive blood cultures of interest and also supply real-time data for patient care. Another reason why we tried it is there was some initial information available through posters at ECMID. I'm only presenting one poster that was presented. The speaker following me will discuss a lot more data concerning his experience with the ARC, but the identification, as you can see, using the Brooker biotyper gave you some very nice high identification scores and good percentage of identification. On this table, you can also see that the MS system did not do quite as good a job, and this was explained in the poster. If you look at this poster, which is online, I believe, that the identification on the MS system, it was a little bit delayed. It was done off-site, and they thought that might have attributed to some of the lower scores. The ARC processing is really quite easy, as I said. You start off with your positive blood culture. You then vortex it to make sure that it's well shaken. You take about 1.7 plus or minus 0.2 mil out of the bottle. You can see the two components that are part of the ARC system in that picture, and you have to put the blood into the plastic white container. You put the separate processing cartridge into the ARC along with the blood, and then you just close up the system where it runs for 72 minutes. We wish it would be faster, but it is 72 minutes. Following that, you have to vortex the sample for 5 seconds prior to MALDI spotting onto the target plate. You put 1 microliter of sample, usually 2 spots are sufficient, allow it to dry, add matrix, and then if it's a gram-positive organism, it's best to add formic acid. This is our potential ARC workflow that we thought of at Cedars. As I say, every lab is different, and you may find a different use of the ARC system. We were going to use it to supplement existing systems that fail to give identification from positive blood cultures. We do use the Accelerate Pheno system at Cedars, but not all organisms identify on that system. So particularly for the gram-negative rods that do not identify, we thought this would be a very good use. Gram-positive organisms that fail to ID on our Verigene molecular panel. Defined gram-stain algorithms for other gram-positive organisms, particularly gram-positive rods or gram-positive cocci in pairs and chains that don't have associated resistance markers. Perhaps we could do direct detection from ARC onto MALDI rather than spending the money for the molecular panels. And we are still trying yeast identification. We're hoping that software updates can perhaps facilitate, because we think that would be a great use. And if using this, we think we would have a great ability to supply good information for our stewardship team for patient care. Using this expanded ARC flow, we have started doing some of this, and things that we have found that the ARC concentrate, of course, is not going to be viable, but it is suitable for molecular assays. So even though this is off the package insert, shall we say, you could use it to detect resistant mechanisms after proper validation, such as use the concentrate for the PBP2A assays or things for carbapenemase resistance. You could use it to identify organisms that you identify on gram stain in your positive blood cultures, but they just won't grow out on agar, so you could use it for that purpose. And you could do it, expand further off the package insert as well, and validate it for sterile body fluids that are growing in positive, that have been tested in your blood culture bottles. Our experience to date, we see that we do get an adequate biomass in the concentrate that is prepared by the ARC, and it delivers in this concentrated suspension, will deliver a very good identification on MALDI-ToF. Occasionally, however, you will get a pinkish-looking concentrate. Sometimes those will identify, sometimes not. But when you see your concentrate a pink color, that's a sign that it might be a problem. We've had very good instrument reliability. The company suggests, ARC suggests using 2 spots on a target plate. We're kind of paranoid at Cedars, so we thought, oh, why not do 4 to see how things work? I think we were a little bit over paranoid. I think that 2 is probably quite sufficient, particularly for gram-negative rods. And we found that identification with the 2 spots provided identification with high scores very nicely with gram-negative rods. Good scores, but not as high or as many positives with our gram-positive organisms. And as I said before, yeast still considered an issue. This is applying our workflow further. If we used it on organisms that it did not identify using the Accelerate Pheno gram-negative rod panel, we found a variety of unusual organisms that identified very well. We also tried it on many blood cultures where we thought would have E. coli and Klebsiella and such, and that worked very well also. We had accurate and reportable for gram-positive organisms not on our molecular panels, such as different species of streptococcus, as I demonstrate here, things like lactobacillus as well. We also had good identification with your run-of-the-mill blood culture organisms, such as your Staphylococcus species and Enterococcus. We also tried yeast. We're still working on the yeast. We did have some reportable yeast from the positive blood cultures. I don't know about you, but we're seeing a lot of Candida auris in our area. That's been helpful, but I do not think that we have perfected the technique with a high sensitivity of yeast identification. We're still around 50% or less. And we did try the PBP2A from the ARC concentrate. It works very well on Staph aureus. So in summary, and then I'll let Matt take over, the direct MALDI-ToF testing from a positive blood culture can certainly supply rapid and useful information that can improve patient care and help your stewardship groups really help in rapid susceptibility and help your patients. Manual methods for the positive blood culture concentrations are effective, but they're labor intensive. We found them to be at least 30 minutes of hand-on time, and our techs were a bit resistant. The ARC provides an automated method with greatly decreased hands-on time, around 2 minutes, for concentrate preparation, and it was well received by our staff. And laboratory-specific workflows can be created to supplement existing test systems to provide comprehensive organism identification from positive blood cultures. And as I started off with, we're all different. We have different ways of working in our laboratories, and I think this is a system that you could make and modify to work best for you. With that, I will hand over the microphone to our second speaker. Thank you.
Well, thank you all for sticking around after you've eaten your lunch, and thank you for the wonderful first talk. I'm really grateful to be here and have the opportunity to spend some time really kind of discussing some of the work that my lab has done recently with the ARC, go over some of the data and kind of similar how we might see and how we are going to think about using the ARC moving forward. So real quick, just my financial disclosures for this speaking engagement. And then just like our first speaker, I think although we all follow CAP and CLIA guidelines, every single lab is very different. And when I'm giving my user experience, I really wanted to just talk very specifically about, a bit of my lab, kind of understanding. So when you put into context with your lab, kind of a similar ideas. And so it sounds like we almost have relatively similar labs. So I'm part of the Medical College of Wisconsin. We service Frederick Hospital as well as Children's Hospital. So with Frederick, we have about 1,000 beds and service a lot of these surrounding areas. And then at Children's Hospital, we have about 400 beds. Now, from a clinical laboratory, we'll get into much more details, but we use Versastruct bottles, and it's about 50,000 cultures a year. These aren't positive cultures, but cultures that we put in our system. Of course, only about 10 to 15% of those end up coming up positives, and we're running rapid molecular with traditional AST methods from clinical isolates. Now, myself, I don't spend too much on the day-to-day from the clinical lab side, but I was really brought on to run our clinical research team. And so in our role here, we've done a bunch of clinical trials, kind of focusing with blood culture. We were part of the Accelerate's Pheno clinical trial, but also have experience working with ePlex, IQBA, and Verigene. And so it's really awesome to be able to see these experiences. And then when we start doing workflows and evaluations, having the hands-on with multiple platforms on the market, which is relatively unique in that systems. And so other things we do too is like developmental outcomes workflow, which is kind of what we'll talk about today. So really, I kind of broke up this talk into 3 different objectives. So at the first spot here, we'll talk about, some of this early data, what we're doing with Accelerate ARC, what we're seeing, the study that we're running. We'll then I'll move into describing kind of our laboratory's current workflows, and kind of similar to the previous speaker is kind of what do we see of what we plan to do with it when we bring it actually on live for patient testing. And then potentially talking about future applications that we can do to really kind of improve patient care and lower the cost not only for the microlab, but also for the patient as well. So to start off here is our currently is our evaluation study that we're doing in the lab. So we haven't brought this up live yet, and it's all kind of internal research data at the moment. But we really have kind of two subsets of studies that are being run. The first set is from fresh positive blood cultures from patients. And the other one, because sometimes these rare organisms are harder to get, and we just haven't had the study up and running long enough, some contrived testing. So spiking specimens into blood culture at low dilutions, letting that then go positive into the system and running it there. And so on each of these arms, we have our positive blood cultures that come up. From there, we're running the ARC down to a MALDI and then getting results. And that's all being compared to setting it out on a culture plate from cultures, those clinical isolates, resulting out MALDI and comparing there. And we spotted these with at least 3 tests so we can kind of see some in triplicate, so we can kind of see some reproducibility of the systems and really kind of understand the difference of the score that we get. Now, I know we mentioned a little bit about the ARC workflow, but just in case if you weren't around on it, as soon as you have a positive blood culture bottle, you'll take about 1.5 mils and add that to their capsule. This capsule then will get loaded along with a cartridge into the system. From there, you're at about 72 minutes where it's going to be there. So this is all the hands-on time. It's, again, less than 2 minutes, and then the rest of it's completely automated until basically it gets done. We vortex the sample, and then we spot for MALDI and load it onto the MALDI-ToF to get a rapid result. So if we break up our testing, how do we see? So right now from our fresh testing, so far we've had about 50 blood cultures tested. Over here on the right is just a score value. So we run the Bruker MALDI-ToF system, and the way that it reports out is based on a score. Anything generally above 2 is pretty solid, and you can really trust it and normally report out. However, a lot of data and a lot of research out there really kind of demonstrates even between 1.7 and 1.99, if there is an identification at score, those are generally pretty good. And in our hands and our validations that we've done with MALDI, we'll actually report these out to the clinicians. And then there's the less than 1.7. These are becoming less reliable results, or sometimes it just says no ID. Basically says, we can't figure out what this is, so we're not even going to try to call it and misidentify it, so it's just a no ID. And so you can kind of see, obviously from colonies, we're getting very good results. The MALDI system was developed using colonies, and so, it makes sense that, most of these are coming out as greater than 2, but some of them dropping there, and really only one that we had. But the ARC still performed really well, and we got kind of a little bit of drop down. And I think, when we look at the average score, we saw about a 0.21 decrease overall between the averages. So that probably shifted a lot because you're normally not 2.2, you're around like 2.1, 2.0. And so that probably shifted a decent amount that way. But I think importantly, when it does call out an ID of a result, so far out of our 50, every single time it's gotten a positive result or a result, it was the same as the result from the colony. So right now we have 100% correlation when we get an ID. Of course, not every time are we getting an ID. And so far of these 50, we had 5 that were unable to obtain an ID. Again, it came up as no ID made, and kind of a arrangement of everything. So it wasn't anything specific, but we did notice that there was those slight red pellets after processing on 2 of them. And as the previous speaker mentioned, that's probably really kind of dropping down. There's still some red blood cultures, and how MALDI works, it's all about protein, and so you're probably disrupting that side. Now, breaking it up based on the MALDI score and percent concordance, so at 2.0 and greater, it was 97.1%, and you're like, hey, Matt, you said it was 100%. Interesting, and we'll talk about it a little bit later, we actually found one that we could not actually get the culture to grow on plates. So this is something, technically it goes against concordance, but it was because we couldn't actually get a colony from this. Between 1.7 and 1.99, we had 100% concordance, and then at 1.7, basically when those drop down there, we've gotten so far no ID from any of those. So it's good. It's not misidentifying it. So it's not like we're going to report something that we're going to have to later correct. It's just saying, hey, we don't know what it is now, and then we'll move it on and report it out later. And then from a reproducibility, since we're doing these in triplicate, our scores were really about 0.05 in standard deviation between the 3 spots. So it seems to be highly reproducible if you're spotting it down for the score. With the contrived testing, so again, right now we have about 25 completed specimens. We kind of hit some issues with COVID and staffing that's kind of slowed us down. But we saw a very similar distribution in terms of the score. I don't have the colonies because all the colonies were at greater than 2.0, so I didn't really want to have a green pie for you guys to look at. And so, again, similar to that, when we get an ID, it's 100% concordance. Out of these 4, though, that were below that, 3 of them did give us no ID. There's a stenmal that had a red pellet, so again, probably failed there, and then strepmitis and pseudomonas. So we still need to spike a few more of those to see if this is going to be a long-term issue, potentially, with the growth. And arguably, I will say, as someone who has done a lot of blood culture spiking, it's something weird when you spike blood cultures and grow them up. It never looks like real patient samples. And so, it could be an artifact as well. So we'll really need to get more data with real patient samples to see how well it works out. And in terms of the yeast side, we just haven't run into any yeast yet. We still need to do some contrived spiking with yeast. Now, there is that 3 that were no ID. 1 did give an ID, it was Strep pneumoniae, but that was correctly identified. And the spots were really borderline there. So there was 1 spot that was above 1.7, and the rest kind of dropped below. So this is probably where I'll try to save a little bit of time because we talked quite a bit about this previously. But so the publication here is actually from my lab, the lab I'm in, but prior to my time. And so these scores here are kind of the traditional time we look back at the time to identification for some of these organisms as they came out of blood culture. And so this was pre-molecular. And you can kind of see quite a range, generally around over 20 to, somewhere around 60 hours, even sometimes later than that, is how long it took us to get, from a positive blood culture to a result out to the physician. And of course, molecular has significantly changed that. So anything that's on target, we're getting out there within about 2 hours. And of course, MALDI-ToF and how just kind of rapid and fast and amazing it is to cover there. It's not a novel, concept. And so as it was kind of brought up before, there's been a lot of LDT methods out there. In general, they found about 80 to 90% identification rates, ranging with percent concordance, and it's probably a differentiation of, was it gram-positives, how many yeast that were running there, and identification rates around 10 to 20%. And then the Bruker sepsitotype are obviously a commercial processing kit, which is around kind of that 15 to 30 minutes of hands-on time. It's very manual. We used, I know for the publication we pointed out there, we were using extended direct transfer, so adding formic acid on every specimen, which can help, especially on gram-positives and yeast, to improve identification. But otherwise, outside of that, from validation I found on their website, they found around 82% identification rates with some no IDs around the 18 to 20%. And we found about similar that when we evaluated around back in like 2012. And so just kind of summarizing where we're at right now with the ARC data, we're at 100% concordance. That could change, honestly. We're at N of 75, so it's still pretty low, with about a 10% no ID rate. And so, if nothing else, it's on par with everything else we see. Potentially could end up being slightly better performance in the long run. But we'll need more data to really identify that. So what are we doing in the lab, and how can we see this actually really becoming give more clinical utility than initially thought of. So in the lab, as it is right now, we have our blood culture bottles. These come through, basically multiple ways, either brought in every few hours or sent us directly through our tube systems, and they get put into our VersaTrack instruments. Now, these are, unfortunately, because of size and how many we have, are not standing in front of our techs, and so our techs get up every at least minimum 2 hours, go look at these, look for positives and pull them. So technically, from that time, incubation can range depending on the organism, and you really have about 0 to 2 hours from when it goes positive before we actually really have a gram stain, just depending on, did the tech get up right as it went positive, or did it go positive right after our tech looked? So based on the gram stain is how we then differentiate. Now, everything from a gram stain, we're going to plate to blood, McConkey, chocolate agar, anaerobic plates if it's coming from an anaerobic bottle. But when we get either gram-positive cocci or we see gram-negative rods, we're right now running a molecular ID. Specifically, we're running the Verigene 1 system to give that. And so based on, we'll give a result to the physicians as that comes up. Otherwise, if we aren't going to run molecular, we will give them a result of the basic the gram stain. Of course, all those then come up culture. As they come up on the culture, we'll either, if it's looks like E. coli, smells like an E. coli. They might not run the MALDI, but just for confirmation, often we'll run the MALDI, say it does match. If it didn't have the Verigene result, it'll definitely get a MALDI-ToF. get that result. And then from the results, we're doing rapid AST of the BD Phoenix right now. That probably does about 90% of our AST testing at the moment. So thinking about the ARC, what are we thinking about where we're probably going to bring it in at? So we're thinking about this of really adding it on as at that gram stain, as we're plating it out and setting this up and prior to the molecular testing. So when we're thinking about this and talking with our lab director, at least at Children's, what we're thinking of doing is changing our workflow so that on first bottle positives of patients, when they have the gram stain, or when there's new bottles with different morphologies, we collect 3 bottles, or we try to. So we're really only testing the first bottle. Same with our molecular, unless if there's unique gram stains coming up. So that just kind of reduces the over testing. Hey, it's E. coli, it's E. coli again, as it goes down that line. So where we can get utility from, though, is when we think about possible contamination, whether this is staph epis or other kind of gram-positive cocci, coag-negative staphs. If we run the ARC, we can get the ID, and then based on that ID result, if it's a coag-negative staph, we don't really need to run the molecular. Maybe it's only a single positive that came from the patient, and so we're only really dealing with this effort, and we're getting that result out. There's other systems where, molecular technology, sometimes the ID is really where you get your clinical utility, and so if we're getting an ID already, those things like streptococcus, where there's no really genotypic phenotypes that are going to be able to get kicked up from there, there's really no point of us doing any additional testing on it. So if it comes up as streptococcus, stuff like that, we'll stop it there, we'll ID it, and then do further ASTs as needed from the plate. And then also kind of going down that route, really remove some of that molecular testing for those off-panel targets. So with the Verigene, you don't really get any gram-positive rods, yeast aren't really there, and there's some rare targets that, again, if we get the ID first, we know it's not going to have any utility to actually run a molecular test at the end of the day. So we can hold off on that testing. And then, of course, everything there, we get our E. coli's that come up. We're going to want to run some sort of molecular test or something else to try to get some sort of rapid AST method that might, downstream help patient treatment. And so really and truly, the thought process for us here is to kind of overall reduce the costs for the lab, but reduce the costs on the patient as well, and really expand that coverage of identification. Molecular panels only have so much space on them. They only have so many things they can identify. And as discussed, MALDI can really hit things that honestly we see and none of us have ever heard before in the past, but lo and behold, it's correct. So I went back, obviously we haven't put this into practice, so I went back into the kind of a past 3 months review of our blood culture systems. And so as we break it out from February to March, we had about 875 positive blood culture bottles that came up. Of course, as I mentioned, we'd only be working with unique IDs or unique organisms, and so that dropped us down to about 550 patients that kind of came through this number set. And then just for ease and discussion of the data, I removed those that were polymicrobial. Just like any limitations with MALDI, you might pick up things that are the most prevalent, but MALDI-ToF isn't great at picking up polymicrobials. And I also removed things that just didn't have an ID. I'd have to do some chart reviews to see why it wasn't there. It might not have grown out in culture, and we only had a gram stain, but it was hard to really say how well, where do we bucket this if it didn't have an ID, so I just removed those. So from this review, we're at about 479 monomicrobial ID results. There was about 12% were polymicrobial, which is kind of be expected, kind of right in the range of the data out there. And the majority of these were coag-negative staphs, and there were some staph hominis, staph epis that popped up in those patient populations. So if we look at currently on target and what we have, so category here of our gram stain, and the number of gram stain cultures from that 479. So with GNRs, we had about 123, gram-positive cocci, 323. And when we look for these on target panels, we found about 83% of our gram negatives were on target for a Verigene. Gram-positive cocci was about 86.4%. Of course, GPRs and yeasts are not on target. So overall, from the 479, about 80% of these were actually on target with our molecular platform at the moment that we were testing on. And a good chunk of these, 101, were staph epidermis. Now, I wish I had time to go back and look at a little more. Maybe it was just a weird snapshot, peak COVID times as we're kind of still coming out of it, where we're getting a lot of staph epis, but we did notice a decent amount of these staph epidermis, which in the long run, we probably wouldn't actually follow up with molecular. So what are some of these off targets that were here? What we found were the decent amount of anaerobes. Those just aren't on really on molecular platforms like Bacteroides, Clostridiums. Those weren't getting picked up. And then some of those rare off-target organisms that weren't anaerobes, maybe one or two of that popped up. We didn't run into in the last 3 months, but I think it's important in terms of, are these off-panel targets really that important for ID? But with like stem malls and stuff like that, the empiric treatment would actually not cover in most cases. So you'd actually want to escalate to different treatment coverage based on having that ID. So then what I took is, all right, we have these workflow changes. What happens if we would have implemented the MALDI plus the ARC plus MALDI in these cases? So a little bit breaking up the data a little bit differently. So we have our possible contamination, 204 cultures. And what I define by that is, was it a coag negative staph, with the exception of Staphylococcus, just because that's a well-known blood-borne pathogen. Your Micrococcus, Corynebacteria, Bacillus, Lactobacillus, all that fell in there. And in the long run, when we looked at those, we had 204 that, arguably you could have potentially said were possible contamination. Then looking at, I mentioned minimal genomic resistance value. So really the ID is the identification, what you want. We found 42 of those that were like strep or listeria species that came out. So far, 42% of our possible contamination, almost 10% at minimal genomic resistance value, and then another 54 that were off-target panels. And so in total, what this ended up giving us at was about 62% of our bottles, almost 300 specimens were either, kind of fell into that range where had we changed workflow, we would have actually not run a molecular test on it. And I will say back of the envelope calculations here. So if we took those 300, we had 3 months, we times that by 4, so you have 1,200 potential molecular tests that you yourself aren't going to be running. And that really cost reduction can be about 60 to 162K a year from the lab. And this is all estimated on, that each of your molecular tests is somewhere between $50 to $135 per test. I will note that, I never like getting into the cost. I don't know what the ARC cost will be. Go talk to a representative if you really want to, because, it always changes probably by volume load. So this number will drop down because it'll add in the cost of that. But I would assume the cost of the ARC would be less than the cost of your molecular test. And cost of MALDI is essentially nothing once you have the system. So like I said, and I think all new technology, everyone loves, that, cool, this was a really cool patient case. And even though we only ran 50, we actually ran into one of those moments. And so we had a 59-year-old female, cancer patients presenting with low-grade fever and anemia. And we drew blood cultures on 12/2. Now, we hold our blood cultures for 5 days. And right at the 5th day, the anaerobic bottle ended up going positive. And from that, we did a gram stain. It was a GNR. Of course, we ran for Virgin, even though it doesn't have anaerobes. You could have an E. coli that was stunted and still grows up, or some sort of other facultative anaerobe in there. And so that came up not detected. So, of course, all right, our backup is culture. We plate these out on anaerobes. Well, unfortunately, at 48 hours, we were still getting negative. So we just could not culture this organism. At this point, on 12/10, the lab director actually authorized and asked my team if we could run an ARC on it. And of course, when they talked to the physicians and stuff like that, flagged this is research, but this is what it came out to be, was a Prevotella, and the score was greater than 2.0. So something where this happens in a real patient cases, and arguably the chances of this patient like getting life-saving treatment might be different. But with a Prevotella, we know it's anaerobic. We can switch it, we can de-escalate, so that patient's not on these, large empiric treatments for this. And so we could really customize the treatment based on that ID there. So something like metronidazole specifically to cover that patient. So that patient ended up recovering and was discharged eventually. But, something that interesting out of 50 that we did find a case so far where, this actually would have had a significant impact on patient care. So to kind of summarize up, and I want to make sure we get plenty of time for questions and stuff like that. So, the ARC, again, it's what we like about it is that automated system. We can probably have our techs do something like the sepsi typer, but in the long run, that would probably be first shift. We wouldn't want our second or third shift that maybe is a little bit more of a skeleton crew to really try to run that because it is really disruptive to the workflow. So far, the data is looking really good. We're getting about 90% identification rates. And when we identify something, it has basically matched our culture results. in terms of the pros, obviously it's, going to be less expensive than molecular testing, and it's going to cover that wide range. There are some cons. There's obviously no resistance information that's coming off of this. So you might not want to fully get rid of a molecular, and depending on your workflow of it, you could potentially, reduce the time to genotypic resistance. Not by a lot, but like if we implement it the way that I suggested, we'll get that ID. That's about, say an hour, 80 to 90 minutes, and then we would set up a molecular test. So it would be, 3 to 4 hours to get a, say that it was a CTXM E. coli versus that. So there's some, and I think that's just going to be each lab's, preference going down that route. And again, in the long run, we found about 68% of our cultures, we probably could have gotten rid of a molecular test with using this system. But what I think is actually really interesting, and I think what we're going to see moving forward actually in clinical microbiology is how we're actually thinking about these patients. So if you think about it, you can maybe really think about an advanced workflow based on an ID. So maybe you come up, and I think you guys were running PP2A, and so you get your ID, and then, it's a Staph aureus. Let's run something a bit more rapid or cheaper than a molecular test, because now we can target specifically the resistance that we want. And so you could really look at that, CARBA-R type stuff out there. Of course, all this stuff is not, on the package insert, so it would be validations on yourself, or sometimes some of these are from blood cultures, and so you can pair those technologies. And then otherwise, outside of that is what you're seeing, and I'm sure you can pop around the boost like that, or even the pheno system here is this rapid AST without ID. So that's kind of what I'm seeing kind of the new trend is. There's a lot of great ways to get identification, but that rapid AST is, you don't want to hold up AST results for ID. And so new systems are coming out every day where you're getting that rapid AST, whether it's MIC or some sort of, breakpoints. But that happens there, and then you can use this. So you can use MALDI and do parallel testing, whether it's the pheno or it's something like Affinity Biosensors, where you're running basically side by side and then getting results out. So instead of waiting, 24 to 36 hours to get a full AST, or setting up stuff, you can get truly 6 hours with relatively cheap direct testing for patients. So thank you all for joining us, and if anyone has questions, come up. Otherwise, thank you.